Okay, we'll continue. Let's solve number 2. Okay, a watermelon was dropped from the top of the tower. So let's say this is the watermelon. It takes 3.34 seconds to reach the ground. So this is the total time. So we have to calculate the height of the building in meters. So distance is missing. Well, the VI, or initial velocity, is 0 meters per second. VF is, we don't know that. So what do we have to do? So if you want to calculate the height of the building, it's gonna have to involve a formula with time. Yes, distance is equal to VIT plus AT raised to 2 over 2. But then we don't know what acceleration is. But then this is not like the usual questions that we answer. Unlike the ones in the previous videos, the ones before this, we will, instead of acceleration, we put G. Instead of A, we put G. G is basically gravitational acceleration. Since the ball is going down, Earth's gravity, it measures 9.8 meters per second squared. And since it goes down, the value is positive. So distance is equal to VI, which is 0. Time is 3.34 seconds. Gravitational acceleration is 9.8 meters per second squared times time. Time is 3.34 again. And divided by 2. This one becomes 0. 9.8 times 3.34 for a while. I'll just summon my calculator. In the meantime, 9.8 times 3.34 is equal to 32.732 divided by 2. The answer is 16.366. The distance of the building is approximately 16.37 meters. Just to be sure, I'll double check based on the answer key if I got it right. Oh, yeah, I made a mistake. There has to be a raised to 2 there. Now that you know, make sure you don't repeat the same mistake. So, shoot for a while. 3.34 times 3.34 is multiply it with 9.8, you get 109.32488. Make sure you write everything just to be safe. And then divide it by 2. The answer is 54.66244 meters. Simplify that, round it off in a way. Maybe this would do. Let's see how the answer is rounded off. 2 digits only. Okay. Alright. So the only reason why I'm kind of paranoid in a way, in terms of needing to write all of the numbers. Well, it's you don't really have a choice. You have to write everything, or at least 4 digits or 5 digits, if it's a non-terminating decimal, just to make sure that your answer in the end is accurate enough. If you have to round off the answer itself, well, it's important to see if you're allowed to round it off to um, only 2 digits, or you have to write everything again. But if it's usually the answer, uh, usually you don't have to um, not round off anymore. So, okay. Number 3, we have the Eiffel Tower. So, apologize for my, sorry about that. Is it still here? Okay, good. Um, so we have, apologize for the drawing, that's not drawn to scale, but the height is said to be 300.5 meters. So assuming there is no air resistance, calculate how many seconds, so time is missing, for the ball to reach the ground. Vi is equal to 0 meters per second again, and then Vf is also missing. D is equal to Vit. No. Oh yeah, I almost forgot. We have gravity. That's always going to be a constant. We don't have it right now. It's not exactly given, but in terms of falling objects problems, that's already a given always. So let's look for the time. G is equal to Vf minus Vi over the total time. Gravity is equal to Vf. Vf is missing. That's the thing, we don't have the Vf. What do we do? Yeah, let's try using the formula we used earlier. So distance. Oh yeah, that's actually a better decision since we have the distance value. So distance is 300.5 meters. Vi is 0 meters per second. Time is missing. Gravity, acceleration, and then time again divided by 2. This will cancel. I suppose we have to multiply both sides by 2, so 600.1. No, 601. Divide both sides, I suppose, by 9.8. What do we get? I'm starting to think that there are no units that will be cancelled. Everything will be m raised to 2 over s raised to 2. But then if we if we place a radical sign, then we'll have, never mind, please discard what I just said. 601 meters divided by 9.8 meters per second. Yeah, the meter unit will cancel. Imagine this is reciprocated already, and the divide sign is already removed. So apparently we have 61.326530612. That's long. Okay, don't forget the unit. S squared. And place a radical sign. What is the answer? Approximately 7.83 seconds. Let's see if the answer is the same. Alright, good. 7.8311. That's what I was telling about. Usually the answer can be rounded off in 2 digits, but yeah, just like the previous answers. But then here, my professor's answer is said to be 4 digits rounded off. So yeah, it depends. Kind of strict in that regard. I don't see the point of being strict in that regard, but I know it's important in the aspect of engineering. You have to be really accurate. That's basically the motivation for being so strict. Anyways, fruit from a tree had an impact velocity. So impact velocity is, in other words, final velocity. How do I know that? So you just think about it. By the time an object hits the ground, uh, the final velocity is usually what we have in mind. It's not the initial. So yeah, that's the final velocity. Neglecting air resistance. Distance is missing. How high was the fruit from the tree? Time is missing. I suppose we do have gravity. Vi is 0. Oh, okay. Literally, these are the only given ones, but these are already implied. Okay, so let's use the gravitational acceleration formula to calculate the time. So we have 9.8 meters per second squared equal to Vf. Vf is 98.5 meters per second. Vi is equal to 0 meters per second. Time is time. And you just switch these in terms of their position. 98.5, sorry, 9.85 is 98.5 meters per second over 9.8 meters per second squared. Time total is equal to what? 98.5 divided by 9.8. The answer is 10.05102, or just 10.051 seconds. Let's double check. Bruh. Oh wait. No. Uh, yeah, this is the time, but we're actually supposed to look for the distance. So, wrong formula. I didn't think we had to, based on the answer key, I didn't think it was necessary to look for the time, but we got it anyways. Let's try the other formula. The one that's not this, just to see if the time is also correct. D is equal to VIT plus GT raised to 2 over 2. Distance is missing. Vi is 0. Time is, well, we know it as 10.051 seconds. We don't have space again. It's always like that. Okay, G is 9.8 meter per second squared. Time is missing. Divided by 2. Joke. Time is already given. Why do we keep forgetting? Anyways. 10.051. That's just weird. The answer before even dividing it by 2 is already Hang on. Oh yeah, meters divided by 2. If you divide that by 2, then the distance is no longer the same as this. So that means there's something wrong with the time value. Disappointment. Apologize for the wrong solution. Alright, let's use the other formula where we didn't have to use the time value. D is equal to Vf raised to 2 minus Vi raised to 2 over 2G. I think I remember it right. Yes, 2G. Since the original formula was 2A as the denominator. A for acceleration. Anyways, I'll just write it. Two times G. G is 9.8. I'll just get my actual calculator. Whoa. Why did the calculator say 1? That's weird. Wait a minute. No. This is so weird. Yeah, the calculator just said that it's 495 meters. So that means this might be correct. Is there something wrong with the teacher solution? I think that's what's up. Yeah, because if you divide 990.021, you get 495.0105. It's not so far from what we have right now. Let's see. Let's see if the calculator says the same thing or otherwise. 98.5 raised to 2 over 9.8. 98. It says 990. What is wrong? Oh, wait. Yeah, as you can see, there's supposed to be a times 2 here. So, yeah, this is supposed to be 19.6. 98. This thing divided by 19.6 is the half of 990. So, yeah, I suppose the answer key is wrong. This is correct. Let's be happy anyways. We solved the problem using the two formulas. It just shows how flexible the computations can be. But then I'm not saying that all the computations are flexible. It's just during certain circumstances, we can be flexible. Just make sure you know what you're doing. It then leads us to the idea that the time value is correct. I'm glad it's correct. Okay, number 5. If you were to drop a large log over the edge of the Grand Canyon, it took 5.55 seconds to hit the ground. Okay, so this is the log. This is the Grand Canyon, like the height. Okay, so this is the distance. Distance is missing. 5.65 seconds for the time. VI is 0. VF is missing. That's what we're looking for. The velocity of the log at impact. And oh wait, this is not related, but I am considering making a video teaching about logarithms. Wait. Yeah, just logarithms. Among other things that I plan to make videos of. I'll just list them here for a moment. You can skip this part, but yeah. Coming soon. We have molarity, molality, molar mass. What else? Oh yeah, log. Log to exponential functions, I mean. What else? Like solving arcsine problems like these. Unfortunately, I wasn't able to study that for the DCAT, but yeah, the school never taught me these. Actually, this one in particular, this lesson. What else? Oh yeah, the types of distributions in statistics, particularly 3 things: binomial distribution, Poisson, and hypergeometric. Let's see if I still remember the formulas. Binomial. P of x is equal to... I'm so sorry. This is supposed to be a video for physics, but this just came into my mind. I just wanted to showcase what I know, what I prepared for the DCAT. DCAT is, by the way, the college entrance exam for the LaSalle University, and fortunately, when I took it, I was looking for questions related to any of these. I think only 1 or 2 appeared. Gosh, I took so much time studying for these. Binomial is the permutation NCX times P raised to x times Q raised to n minus x. I remember it. Nice. Poisson is mu raised to x times e raised to negative u. Uxel, u x e u, uxel, divided by x factorial. For hypergeometric, it's p of x is equal to... Oh no. Oh yes, I remember. S c small s times n minus s c. Sorry, these are all capital letters, and then small letters at the very right side, divided by n c small n. Nice, I still remember them. is actually nice. Another formula from logarithms, one property is that if this is log ax, this is, sorry, bag. We have a here, and then we have b here. We have then ba. No. Shoot, I forgot that part. But yeah, I'll be covering these topics in the next videos to come. Credits to our chem tutor for teaching me when my actual teachers couldn't really teach me. But I don't entirely blame them. It has something to do with how fast the class is in terms of learning the lessons, and yeah, the teacher just had to be somehow slow. My class isn't exactly the most academically inclined, the most motivated, and I was a part of that community, of that society. Anyways, calculate the distance the log fell in meters. G, by the way, I almost forgot G, 9.8 meters per second squared. Let's try this. VF is missing. How about VI? VI is 0 meters per second. Time is 5.65 seconds. Multiply both sides by 5.65. The answer is 55.37. I suppose that is the answer already. Is it? Okay, 55.37, that is correct. Okay, distance is missing also. Let's calculate for it. What is a good formula? Just to be safe, you can't really be sure with your own answer. So you want to play it safe, use a formula that does not utilize any value that you just found. So in that case, that is d equal to vit plus gt raised to 2 over 2. Why? Because there is no final velocity here. And yeah, just in case the inevitable happens and your VF is wrong, your other answer could still be correct. So yeah, that's just one of the tips that you could use for the exam, especially if getting a high score is really the main priority and you're not losing any chances as much as possible. Do that. (9.8 times 5.65 raised to 2 divided by 2. We have 156.42025. This is in meters. We have the same thing with the answer key. 156.4203, correct. Okay. Let's move to number... Okay, we're at the next lesson. Although it's not so far from the context of what we just did. So a ball is dropped over the edge of a building. How fast is the ball moving? 2.0 seconds after being dropped. We don't know if this is the total time, but yeah, we do have a time value. So dropping an object, VI is 0. Vf is unknown. Oh yeah, Vf in the sense that the time is 2 seconds. That's what we're looking for. Gravity is still the constant 9.8 meters per second squared. The distance is missing, I suppose. Okay, uh, let's try this. Gravity is 9.8 meters per second squared. Vf is missing. Vi is 0 meters per second. Time is 2 seconds. Sounds fair. 9.8, that's 19.6 meters squared second squared. Are we supposed to square? I mean, place a radical sign. We can't have a unit that's all squared, so 4.42719. Wait, no. But then, yeah, the value is already the answer. What we have right now. How do we cancel the meters per second unit then? Like, it's raised to 2. Let's see what the answer key has. Oh, I'm so sorry. If you multiply both sides with 2 seconds, the s squared at the denominator will be just s. And then, yeah, that is the answer already. Why did they put meter squared in the first place? That's just really weird. Okay, a rock that is dropped from the bridge is 28 meters above a river. How long does it take for the rock to hit the water? Vi is 0 meters per second. Vf is missing. Time is, we don't know that. Okay, so we have distance. We do have the initial velocity. We do have the gravity. So let's look for time. 28 meters is equal to Vi. Vi is 0 meters per second. Time is missing. Gravitational acceleration. Always write that. Time, then raised to 2 divided by 2. 28 times 2 is 56. So, yeah, 56. So 56 divided by 9.8, that is equal to 5.714. 2 or 3. And then place a radical sign. .3905. Oh yeah, don't forget the unit. Seconds squared. We have seconds. So 2.39 seconds. We have the same answer as the answer key. That is good. A ball, sorry, is my microphone okay? Okay, good. A ball is thrown straight upwards, reaches some. Okay, so it's our first time to answer a problem related to a ball being thrown upwards. So as I said, the gravity, first things first, that's gonna be negative. We are going against the force of gravity, so it's right to say that the value is gonna be negative. So the maximum height of 4.5 meters, that's gonna be the distance. And then at what speed was it thrown? So we're looking for the initial velocity. The starting velocity is usually 0 if it falls down, if it's being dropped, if the object is being dropped. But right now, the VI is actually the maximum value. VF is going to be the 0. Because by the very moment the object starts to lose, well, at the beginning, it should already start losing momentum as well as kinetic energy. At some point, it will start to fall down again. So what do? We have gravity. We also have, do we have time? No, we don't. So what do? Sorry about that. We do have the distance. Distance is 4.5 meters. VF is 0. VI is missing 2, and then we have G as negative 9.8 meters per second squared. Multiply both sides by negative 19.6. 4.5 times 19.6. We have 88.2. Don't forget the negative. And so negative will become positive, square root VI is equal to square root of 88.2, 9.3915. Okay, so far so good. What's number 4? A soccer player heads the ball and sends. I think this is, I'm not really, based on my local culture, soccer isn't really popular, so I'm not familiar with what head means, but in movies, I think I've seen it. The head of the soccer player, he usually headbutts the soccer ball. I don't know if that's how that's okay, but yeah, the head, you usually are not supposed to have it hit by something. You could get a head injury, or maybe the ball isn't too heavy. Since it's flying vertically upwards, so yes, I know it's realistically, if someone tries to headbutt a soccer ball, it would not only go in a single direction, like in this case it only goes up, but considering in reality it will always usually go that direction or that direction. But then yeah, let's just disregard that idea. Maybe if it's performed by a robot, and all things considered, the direction will only be one direction. Vertically upwards at a speed of 12 meters per second. What is this? Is this the velocity? What? Velocity initial or final? I suppose this is the initial velocity, because by the moment it reaches the top, it will become 0 meters per second. So how high above the player's head does the ball travel? So imagine this is the player. Doesn't look realistic. The ball is a lot bigger than the human itself, but this is what we're looking for. We're not looking for like the entire height, including the height of the player. Uh, so distance is therefore missing. We have to look for the time. I'm sorry. The time isn't really given. We don't have it too. So even if we wanted to look for the time, it's not really a requirement here, based on the instructions. We could look for it, but yeah, let's focus on the distance first. Gravity. Don't forget the negative. Okay, so G is equal to Vf minus Vi divided by 2G. Sorry, time. We don't have time. Okay. What do we do? Oh yeah. To look for the distance, you don't use that formula. Distance is equal to VIT plus GT raised. No. We don't use that. We don't have the time. Let's use the other one. Vf raised to 2 minus Vi raised to 2 divided by 2G. Will that work? Yes, it will. So Vf is 0 meters per second squared minus Vi, which is 12 meters per second. Put a squared. 2 times G is negative 9.8. Okay, so the negatives will cancel based on what we are seeing right now. $19.6. Okay, so the answer is going to be 7.34694 meters. For a while. Let's just see the units. So meters per second squared, meter squared per second squared, divided by meter over second squared. Okay, yeah, the final unit is meter. A snowball is thrown upward at a speed of 27 meters per second. Time is missing. Okay, so that's a second requirement. How high was it thrown? Okay, so given that, time isn't actually missing. We do have 3.5 seconds. So distance is missing. They are related, these two. How fast was it moving at that time? So yeah, velocity final and distance are missing in the context that the time is 3.5 seconds. We cannot say that this is the total time because yeah, just think about it. It can be somewhere within these parts, but it would never be at the very edge, at the highest point that the snowball is flying. Flying? No. The snowball is thrown, doesn't fly. In what direction? What direction? Well, let's just. I think we can already solve this. Thrown upward. So. Wait, no. Uh. Oh, okay, I get it. Yeah, let's just calculate first. D is equal to VIT plus GT raised to 2 over 2. Soon after, we're gonna have to standardize our our way of writing the given, because at this point, if it's thrown upward, and it starts to go down, we do have different givens for each direction. So this is the gravity going up, and then we have a gravity going down. So this is what I mean. You have to organize it in a table so that it's not confusing. Distance is missing. VI is 27 meters per second. Time is 3.5 seconds. G is negative 9.8. This is the distance going up, and then time is 3.5 again. Okay, so we have 94.5 meters. Okay, so it's a negative value, so disregard the plus sign. There's gonna be minus 60.025 meters. So 94.5 minus 60.025, that is equal to 34.475 meters. Let's look for the velocity. Velocity is equal to, right, let's find the unappropriate formula first. An appropriate formula would be, say, we do have the distance. Wait, final velocity. Found it. D is equal to VIT plus GT raised to 2 over 2. Distance is 34.475 meters. VI is always, it's gonna be 27 meters per second times the time. Time is 3.5 seconds. Shoot, we need more space. I'll just move this thing here. Oops. Never mind. What's the time? 3.5 seconds. Wait a minute. Something's suspicious. We were supposed to look for the final velocity, but it's not there. Let's try the other formula. This is so funny. G. Okay. VF is missing. VI. Okay, so 34.475 times 19.6 is equal to negative 675.1. Sorry, 71. And then meters squared over s squared. Actually, let's transpose this already to the other side. 27 raised to 2 is equal to 729. So plus 7 29 meters squared over s squared is equal to Vf raised to 2. 729 minus 675.71 is equal to 53.29. Find the radical sign. Vf is equal to 7.3 meters per second. Did I get it right? Okay, so 7.3 meters per second, and what direction? This is gonna be some kind of challenging to me. What direction? Because based on the answer key, uh, the distance that we have as well as the velocity, it has to be going down. Maybe. Wait, never mind. Because either way, if the initial velocity is 27, and that's already the highest that you could have as a velocity value, the final will always be smaller than it, the farther it goes upwards. So we do have a final velocity of something that's less than 27, which is 7.3, but we don't know if the direction is going up or down. It says here it's down, but for what reason? Wait, I'm looking at a different thing. Sorry. Okay. Yeah. Something's really up. Okay, this is how we try to identify the direction. We're not going to use the time 3.5 seconds. We'll solve for that. But in the meantime, we have gravity. So VI is that gravity going up is negative 9.8 meters per second squared. Distance is missing. Sorry about that. Our VF is also missing. No. It's already given as 0.0 meters per second. This is that the time we don't know. I think we have everything. What else do we do? Right, we look for the distance. Let's use this formula since we have VF and VI as well as the gravitational acceleration. Yeah, bro, we actually need more space. I just hope that no computation is too hard. You have ample scratch paper during your exam. It's hard to mentally solve everything, or at least majority of it. You most likely end up with the wrong answer, especially if you mixed up your writings. Okay, so distance is negative, well, cancel the negatives already. 27 raised to 2 divided by 19.6, that is equal to 37.1939 meters, or just say 37.19 meters. So this is the distance going up. Let's compare that with the distance that we just found a while ago. This is 34.475. This is 37. That's interesting. If you think about it, the distance for this, since it's lower than the distance by the time the final velocity reaches 0. Wait, what kind of final velocity are we talking about? The one going up or going down? That's the question. I'm starting to think this is not down for that reason. Let's look at the time. The moment the final velocity reaches 0. Okay, d is equal to no. Let's use the acceleration. 9.8 meters per second squared. Vf is 0. Vi is 27. What is the time? Time is missing. Sorry, I'm so accustomed to using time total. This is supposed to be an arrow going up. So time going up is equal to negative 27 meters per second divided by 9.8 meters per second squared. Two point 2.7551 seconds, or just 2.76 seconds. Let's compare that with the time that we have here. Okay. It's a lot clearer now that we know the time. I'm not sure why the distance, it doesn't explain the reason why the direction is going down, but here, oh wait, yeah, it does make sense. I don't know what the heck I was thinking a while ago, but the distance of going up, the moment the velocity goes down. No, wait, never mind. This is so fun. Let's figure out the reason why the direction is going down. We using the time that we have. So time going up is 2.76 seconds. The time at 3.5 seconds. This time is lower. So by the moment the ball, is it the ball? Yeah, it's a snowball. The moment it reaches its highest point, this is 2.76 seconds, it starts to go down. So as it starts to go down, that means the time value has to be bigger, in which case the time value here, which is 3.5 seconds, it should somewhere be here. So it makes sense to say that the direction is going down. I'm not sure why I cannot explain it using distance, but we got it anyways. So time going up is 76, and the other one, the given time is 3.5 seconds. (75 seconds) or just 3.5? I keep forgetting. 3.5. I always overthink. Anyways, so 3.5 minus 2.76 time going down between peak and the location of the ball at 3.5 seconds. So yes, direction going down at 3.5 seconds. So yeah, we solved it. Let's move on to number 6. A golf ball flies straight up in the air. Exactly 4.0 seconds later. Okay. VI is, we don't know it. We don't know the information.